We are starting Unit 4. It's called Function Operations. So what we're going to do is we're going to start off in your packet and we're going to evaluate functions. So these are like little function machines. Let me show you. Get my pen out and ready. So here is a little machine, and what's going to happen is we're going to put something in the machine and something is going to come out of the machine. So we're going to name our functions letters. So this is f of x, and f of x is equal to 3x. So when we come over here and we see f of 5, what does that mean? Well, we're going to write down the function, which is 3 times x, and then we're going to plug in 5 for x, and we get 3 times 5, which is 15. So f of 5 is equal to 15. Take a look at number 2. When we look at number 2, we have g of x is equal to x squared. So everywhere we see an x, we're going to drop in 2b. So 2b in the parentheses, 2b squared is 2b times 2b, which is 4b squared. Let's take a look at the next one. The next one is a plus 1. It's actually an expression, so take a look at the expression. So what we're going to do is we're going to write down the function f, which is 3x, and everywhere we see an x, we're going to replace it with a plus 1. We're going to use the distributive property, and we get 3a plus 3 is the final answer. Take a look at the last one. We're looking at function g. And everywhere we see an x, we're going to take it out and put in 3x. So that gives us 3x. The function is squared, so we square it, and we get 9x squared. This is a review from day 1. Want to get into operations on functions? For any two functions, f of x and g of x. For this particular example, we're going to think of f of x as x plus 1 and g of x as 2x minus 3. So in problem number 1, the notation says to add the two functions together. You may see the notation and it may look like this, and then we may switch it up and it may look like this, but it means the same thing. When to add the two functions, we write them down and we put an addition sign between the two. We add like terms and we get 3x minus 2. The next one is subtraction. We're going to take the two functions and we're going to write those down. We're going to put a subtraction in between. We're not going to forget to distribute. And once we distribute, take a look right here. This negative is going to distribute to 2x, which gives us negative 2x. And this is going to distribute to the negative 3. And so negative times a negative is a positive. Last step, combine like terms and we get x is equal to negative x plus 4. The next notation is multiplication. F times g, or you may see it f of x times g of x, means the same thing. We have to put the two functions together and we are going to FOIL. When we FOIL, we get the first term times the first term, the outer term times the outer term, the inner term times the inner term, and the last term times the last term. We combine like terms and we get 2x squared minus x minus 3. Last here is division. We can divide the two functions. F on the top, which is x plus 1. G on the bottom, which is 2x minus 3. We can't do anything with that. So that was the final answer. We're going to talk about composition of functions. So basically, we're going to put a function inside of a function. So it's going to look a little different than what we just learned. So compositions of functions is going to be like putting a cat into a hat. The second one would be putting a hat into a cat. So our function h of x is going to represent a hat. Our function c of x is going to represent a cat. So when we talk about this composition function, We're talking about starting with the inner function, the cat, and we're going to take the cat and put it in our outer function, which is the hat. Here, what are we going to start with? We're going to start with a hat, and we're going to put it in a cat. Let's see what happens. Here is the cat. He's been put in a hat. Here is the hat that's trying to go inside the cat. So this is just like a little funny thing to help you remember what composition functions are. So let's get started with the math. That was just a fun little exercise to do. So here we go. I want you to pay close attention to the top at the notation. There is a circle here, which means it's a composition function. Something is being put into something else. So just make sure you understand the notation. It can look like h of j of x. It can also be written as h of j brackets parentheses x. Or it can look like h of j of x, and they all mean the same thing. So let's go ahead and get started with number 1. Number 1 reads f of g of x. We can rewrite it as f of g of x. We're going to start with our inner function. Here, our inner function is g, and it is x squared minus 1. We're going to take x squared minus 1, and we're going to drop it into the f function, which is 2x minus 4. Now we're going to distribute 2x squared minus 2 minus 4, and last, we're going to simplify 2x squared minus 6. Final answer. Take a look at number 2. It's g of f of x. G of f of x. We're going to take our f function and drop it into the g function. Our f function is 2x minus 4. And we're going to take that and drop it into the g function, which is x squared minus 1. We have to square 2x minus 4, so we write it twice. We're going to FOIL it out, and we're going to subtract 1 on the end. We're going to simplify it, and we get 4x squared minus 16x plus 15. Now for this particular problem, if there was something you did not understand, you need to pause the video and see your instructor. Take a look at number 3. This is f of g of 3. We're going to go ahead and start with our g function here. I like to start with my innermost function. So this is g. So when I look at g at the top, g is x squared minus 1. Well, I'm not writing x squared minus 1. I'm actually, where there is an x, I'm going to drop in a 3. So instead of x squared minus 1, it is 3 squared minus 1. 3 squared is 9, and 9 minus 1 is 8. So f of 8. So 2 times 8 minus 4, 16 minus 4, which is 12. Let's take a look at the next one. We're going to start with our f function, and we're going to drop in a negative 4. So I'm going to replace my x value with a negative 4. So it's 2 times negative 4 minus 4, which is negative 12. I'm going to take my negative 12 and I'm going to drop it into the g function, and I get negative 12 squared minus 1. Negative 12 squared is 144, and 144 minus 1 is 143. Well, the question is, when can this be useful? Well, let's say you're shopping at American Eagle, and they have a sale, and you have a coupon. You want to know if you should have them apply the coupon first or the discount first. Or maybe it doesn't matter. Well, let's see. So we're going to start off with this function, and our function is f of x is 0.75x. So you're getting 25% off. So you're only paying 75% of the item. So that's where this function came from. So if you get 25 off, 100 minus 25 is 0.75. That's how you do discounts in the store. So our next function, g of x, represents you're getting $5 off the item. So we have two functions. We have a coupon and we have a discount. So we're going to see if we apply the coupon first, what do we get? So the coupon first, g of x will go on the inside. Let's see what we get. We're going to take g of x, which is x minus 5, and we're going to drop it into our f function, which is 0.75. So we're going to multiply 0.75 times x and 0.75 times negative 5. We get 0.75x minus 3.75. So that is our answer for f of g of x. Let me write it right here. Okay. The next one is g of f of x. So what we're saying here in the next one, let's apply the discount first and the coupon last. So we're going to start with the discount, 0.75x. Want to drop that into the coupon, which is x minus 5. Once we simplify that, we get 0.75x minus 5. So the answer to g of f of x is 0.75x minus 5. The question is, are they the same? Does it matter if you apply the discount first or the coupon first? Which one offers you the most savings? Is it 0.75x minus 3.75? Or is it 0.75x minus 5? If you would, write down your explanation and give it to your teacher so that she can check to see which one saves you the most money. And also pick an item that you would buy and show her what it would cost to purchase that item if you did the coupon first versus the discount. That concludes your lesson today. Thank you for joining.